The very first thing is what is VPC and Subnet. VPC stand for Virtual Private Cloud and Subnet. So what you can say a VPC is your own private data center inside AWS. I'm just giving you one analogy. Let me repeat once again. VPC is your own private data center inside AWS. So VPC, what it does, it fully controls IP range, subnet, routing, security, like NACL, security group, internet access, peering, right? So all these things we will learn as part of networking section. As you can see, AWS networking allow you to create, manage virtual network in the cloud. It provides a range of services and tools to help you build secure, scalable network. Now, what we need to understand, the way we had LANs in our colleges, right? In our home, we can have LANs. Without VPC, you cannot invoke any AWS resources, for example, EC2, for example, load balancer. They need IP. Now, IP you will define through VPC. And this is what we are going to learn. So VPC is a virtual network dedicated to your AWS account. It is logically isolated from other VPC. That is what I used a statement. A VPC is your own data center inside AWS. That is an analogy, a simplified statement, so that you can understand it, right? You have full control over your VPC, including IP address range, subnet, and security setting. Now, we have just touched base with VPC, correct? What is subnet? So let us understand what is subnet. A subnet is a range of IP address within VPC. Subnet means subnetwork of VPC. That means inside VPC, you are dividing VPC IP ranges into small subset, and that is called subnet. A subnet is a smaller network inside VPC. What is this? It is a smaller network inside VPC, right? So basically, you divide your VPC CIDR block. I am going to discuss what is CIDR block, classless interdomain routing. So basically, you divide your VPC CIDR block into multiple subnet. So you can separate public workload, you can separate private workload, and management or network management. Basically, you do using uh, VPC and subnet. So subnet are like having different floors. If I give you a layman example or an analogy, what I can say, subnet are like having different floors or department inside the same office building. So you can say you have one office building, that is your VPC, and different floors is like different subnets inside your VPC. That means inside your floor. So each subnet is associated with specific availability zone. We'll see it, but for now, since this point has mentioned in this slide, you can remember each subnet is associated with specific availability zone. It does not span out of availability zone. Clear?
Yes.
Now, as you can see, the first bigger box is representing AWS Cloud, and inside AWS account, we can say, and then we have entire region. In entire region, you have defined your VPC. Can you see this? And inside the VPC, you have your two different subnet, and I have given a very simplified example. That means inside two different subnet, you can see two different EC2. We'll discuss this part in detail, in lot of detail. Now, the very concept, classless interdomain routing, that means CIDR. Now, I will give lot of example. I will discuss lot of examples with you. So we'll try to understand the concept, how to calculate IP address. You must be aware of what is IP address, right? Every resource is tagged with IP address. When you launch, you would have launched EC2 instance during EC2 lecture. So you would have seen that IP is associated with EC2. But the important point is We did not create VPC during EC2. We used the default VPC given by AWS, correct? So basically, we skip that part. But we don't do like this in real world projects. You're getting my point? You have to define the VPC first. Since we were doing, see, in cloud, as we have been discussing, every service is associated with other service. If we are talking about EC2, EC2 has direct relation with VPC. But when I'm teaching you EC2, I don't want to confuse you. That is the reason I did not share the concept of VPC. And I believe for that only purpose, whenever you launch EC2, you get the default VPC so that you can learn EC2. Otherwise, and EC2 is relatively simpler service, right? In terms of concept, VPC is relatively, when I say relatively, if I compare with EC2, complex, right? So now we have some understanding. We have gone through IAM, we have gone through EC2, and now we are learning VPC. So CIDR range is classless interdomain routing. That is how you define the IP ranges. CIDR is a method for specifying IP address range and their associate subnet mask. What is subnet mask? We'll see shortly. It allows for more efficient allocation of IP address compared to traditional classless at classful addressing. You need not to know because we are not we are just we just need to be specific to cloud, right? CIDR notation combine the IP address and subnet mask into single expression. You would have seen this 10.0.0.0/24 or 16 or 192.168.1.0/24. You would have seen this. This is nothing but your CIDR notation, IPv4 CIDR notation. In CIDR notation, forward slash, can you see this forward slash? Can you see this? Followed by a number represent the number of network bits in your subnet mask. For example, /24, that means 24 bits represent the network bits in the subnet mask. For example, /24 means first 24 bits of IP address are used for the network portion and remaining 8 bits are used for host portion. You just need to have some patience because in next slide we will talk about why 32 bits, what are octet, etc., etc. So what is subnet mask? A subnet mask is a 32-bit number that represent network and host portion. Now, whenever you see CIDR block, there are two portions. See, even if I don't tell you this, nobody is going to ask you during interview. I don't think they will ask you. Mostly they will ask you how to calculate the IP address. For example, /24 means how many IP address. And there are different websites you can take help when you start working as AWS SME, subject matter expert, right? You will get the help from different website to calculate the IP range, but it is always good to know the concept. Yes or no, right? So we should know the concept, and that is the reason I could have skipped this portion. How to calculate what I am going to share you in this session, I could have just wrap that section in 5-10 minutes without investing 1 hour. But I thought of letting you know the basics so that it is always nice to know the concept. So a subnet mask is a 32-bit number that separate network and host portion of an IP address. It determines which part of IP address represent the network and which part represent the host. Now you only need to worry about host because host means number of host machine. In simpler words, number of resources you can launch in your VPC or subnet. You are getting my point? In CIDR notation, the subnet mask is implied by the number / symbol. That's what you can see. 192.168.1.0/24. So what does 24 means here? What did I just tell you?
Subnet mask.
Subnet mask, yes, but 24-bit represent the network portion. And 32 minus 24 is equal to 8. That will represent the
Host.
host. always, whenever whatever number you see followed by forward slash, you always have to subtract that number from 32 bit, and that would be equal to the number of host. And you have to, there is a way to calculate it. Now I will share few basic things with you. So what we are going to discuss, this is important, and I'm sure after spending 5-10 minutes, you will have better idea. So for example, what we are learning, CIDR, CIDR, IP count, how to do it. So for example, this is your CIDR, and if you see slash 16, how many IPs, how many IPs, slash 16 slash 20 slash, let's say 24 slash 26 slash 28 slash 30. What did I just tell you? You have to subtract from 32, and that would be your IP inside your VPC or subnet. So 32 minus 16 is equal to 16. So 2 power 16 is equal to, if you do 2, multiplication of 216 times, you will get 65,536. 20 means 32 minus 20 is equal to 12. So 2 power 12. That means 4096. I've done it so many times that I remember all these things, right? 32 minus 24 is equal to 8. So 2 power 8. 2 into 2 into 2 is equal to 256. 26 means 32 minus 26 is equal to 6, right? 2 power 6 is equal to 64 IP. You're getting my point? 32 minus 28 is equal to 4. That means 16 IP. And 32 minus 30 is equal to 2. That means 2 power 2. That means 4 IPs. You're getting my point? So that's how you calculate.
तो इतने आईपी एड्रेस उसको एक्सेस कर सकते हैं. इज दैट द मीनिंग ऑफ दिस आईपी काउंट?
Of course, yes, you have to see when you work as a solution architect, or when you work as an architect, and if requirement comes to you, and we'll discuss that part. So you just bear with, be in this lecture, we'll discuss. ये IP आप define IP reside in. I just told you this is your VPC. This is your VPC. Inside VPC, this is your subnet. Inside subnet, lot of resources. Lot of resources means lot of IPs. Lot of IPs will come from the CIDR range. This will have a CIDR range. This subnet A. This is subnet B. So this will have IP range. And for example, you have 4096 IP. That means 4096 resources can reside here because every resource will have IP. You're getting my point? So you have to define the CIDR range. How would you define the CIDR range? You will come up with the VPC. You will come up with the subnet, because you have to have subnet. You cannot simply launch the resources inside VPC. Inside VPC, you have to divide the network in subnets, and that's how you can make sure the security. Few resources would be in public subnet, few resources would be in private subnet, right? Correct?
Yes.
I'm sure this is clear, and then we will have better idea now. So now you look at this slide. I created this slide, but before that, let's discuss. We have already seen this. Now let's discuss this particular slide. For example, you have your IP range of your VPC, that is 192.168.0.1/24.
Hmm.
Now, before I tell you, are you able to get it? What is this? What is
Yes,
basically this?
yes, it's a binary pattern of a
Perfect. Binary pattern. Yes.
represent number 168 and all that.
So can you see the 8-bit, 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 8-bit? Basically, you have 1, 2, 3, 4.
Yes.
You have 4 octets. So this is called octet. Each octet is having 8 bits.
Yes.
And what we have seen here, because we all are from, I mean, we are engineers, so we did this, I mean, long back, right? How one octet converts to binary. So here, as you can see in binary 1, 2, 3, 4, 5, 6, 7, 8. These are 8-bit. How to calculate in binary? 2 power 0 is equal to 1, 2 power 1, 2, 2 power 2, 4, 2 power 3, 8, 2 power 4, 16, 2 power 5, 32, 2 power 6, 64, 2 power 7, 128. So these are 8 bits, and that's how we calculate in binary. If we sum all these things, it would be 255. Correct? Now, if we need to calculate 192, let's move on to the next slide. If we need to calculate the 192, we just need to have two ones. That means one in the place of 128 and one in the place of 64.
Hmm.
Correct? And rest 0. That would be 192.
Understood.
Yeah. 128, that means, sorry, 168 means 111. 111. And rest 0. I hope you are getting it right.
Understood. Yes.
Yeah. 0, that means
Understood.
all the zeros. And ones means only one.
Yes.
2 power 2 because we start from 2 power 0. 2 power 0 is always 1. So that's how we calculate it.
Yes.
You're getting, so that is how the CIDR, classless interdomain routing, a method to allocate IP address. So this we should know actually. Even if you do not know, there are ways to calculate IP address. You're getting my point.
Yes.
Now let's understand. For example, if you see /24, what does it mean /24? The /24 means first 24 bits are network bits.
Hmm.
What would be the host bits? Now I think you can answer me.
The remaining 32 minus 24.
Absolutely. So this is 32 minus 24 is equal to 8. So 2 power 8 would be the IP, right? Would be the number of IP. So 24 would be your network, and remaining 32 minus 24 would be your host, and number of IP is equal to 2 power 8. So it would be 256, right?
Yes.
Now let's do little exercise. 10.0.0.0/24. Calculate the host IP range from the CIDR address. I think you know it,
Yes.
right? /24 means first three octet will not change. See what we have seen just now in the previous slide. These are 4 octet, octet 1, 2, 3, 4, right? Each digit represent 1 octet. So /24 means 888 is equal to 24, right? Correct? So first 3 octet will not change. In other words, first 24 bits of the IP address are used for the network position. Remaining 8 bits, 32 minus 24, can be used for the host address, and that means 2 power 8 256. So IP range for host address would be 10.0.0 from 10.0.0 to 10.0.0/255. You may have some confusion, but slowly you will get it, because sometime it feels it is straightforward, but the moment you go deeper, you will realize that it is not that straightforward. It is bit tricky, and you need to spend some time. In binary, a subnet mask consists of series of ones followed by zero. The ones always represent network portion, zero represent the host portion. So 24 means first three octets. So 11818181 for network. 81 means 255, 255, 255. Last zero means this octet will only be changed. And that's the reason you can see range here. Can you see 10.0.0.0, 10.0.0? It is not changing, only the last octet is changing. You're getting my point? Because 24, that means first three octet will not be changed. 32 minus 24 is equal to 8. That means only last octet will change. What I'm trying to say, the IP range will, you know, it would be 10.0.0.1, 10.0.0. That means, let me write it. It would be like 10.0, it will not change, dot 1, 2, it will not change. Like
Mhm.
this,
But
10.0.0.255. So overall, it would be
yeah,
256. This is also 1, right? This is also 1. And remaining 255. 255 plus 1 IP, 256. And 32 minus 24 is equal to 2 power 8 equal to
yeah,
256 IP. You're getting my point? Somewhat clear?
yeah.
If not, then maybe by the time we spend more time, it will be clearer.
It is clear.
Yeah. Now we are going to see one example. The question you asked me sometime back, 10, 15 minutes back. Now, this particular scenario may help you to visualize your role going forward. In case, see, what I'm trying to tell you, there are various ways to calculate and you will get the help. But the most important thing, you should know the basics so that you can get the help from various available portal and tools. You're getting my point. If you do not know the basics, how would you seek the help from a various available tool? It's like I always use this example that you also have AI, right? You can get the answer from AI. But
Yeah.
first of all, you should know the concept, then only you can get the better answer from AI. If you don't even know what is CIDR range, how to calculate CIDR, what is VPC, what is subnet, and if client comes to you that Anjali, I need you to design the entire architecture for my application in AWS. So the first thing you will come up with the networking portion. Then what is the range? What would be the range of VPC? How many subnets I need? Two, three, four, five, six, seven, eight. How many subnets inside VPC? Because once you do it, you cannot change afterwards. It's not like that every now and then you are changing the VPC range and subnet. It is not going to happen, right? Once you decide, you have to do it in one go. Otherwise, you will have to shift the entire. Sometimes what happens because of not following the proper practice, you run short of IP range going forward. For example, couple of months, 2 months, 3 months, 4 months, it is fine. If I give you one example that a client comes to, we will definitely go through this example, but you have a VPC, let's say 10.0.0.0 slash, you came up with slash 24. This is your VPC range, not subnet. And you defined 32 minus 24. That means 2 power 8. Correct? Now you define subnet 1, subnet 2. And inside it you define 10.0.0. Now if this is a range, subnet must be a a shorter range because of course VPC is a out VPC is, it has to be bigger than subnet range, correct? Because VPC is parent, subnet is a sub entity. So subnet range should follow under the range of VPC. So you have to increase it, let's say 28. Higher the value after forward slash, that means lesser the IP. You're getting my point because you will have to subtract it from 32. So it would be 4. That means 2 power 4. How many? 16 IP in this subnet. Now go, and then 16 IP, for example, you get in second subnet. What if after few months you need 50 IPs? You cannot have IP. You cannot deploy new resources in subnet 1 or subnet 2 because you are running short of IP. You are getting my point. Every resource needs an IP. For example, you have to create more EC2s. Every EC2 come up with not only one IP. If you attach more elastic IP, I shared this concept with you. You will have more IPs. How would you get the IP? You will get the IP from subnet range. That is why you have to define the VPC and subnet range properly. थोड़ा clear हुआ? Now you can ask me what is host IP. I think I already shared. I talked about two things here. For example, 10 dot. So here, host and network. Network belongs to network. IP belongs to network. But you can ask what is host. That means here 32 minus 16 is equal to 16 is equal to 2 power 16 is equal to 65,000 something. That would be host IP available. So what does host mean? Host IP is a part of IP address that identifies a specific device inside a network. You're getting my point? The host portion, that means this host portion identify which device, for example, EC2, for example, your router, your ALB, these all will have IPs and these all entity will get the IP from host IP.
Yes. That means it will be one, right? Does this mean the same?
Whitelisting is a different thing. Whitelisting is at network level when you allow that IP address to work within that network. That's a different concept. Here we are talking about every resource inside your VPC needs an IP. And how to get the IP, you have to define the VPC and subnet. So your range should be, I mean, all the IPs which you can utilize, your resource can utilize, is decided by host, not network.
I
Okay.
understand.
Yeah. So we can just see one example and let me ask you using this example. For example, you have 192 dot, let's say 168 dot 1 dot 10 slash, this is one example. A question comes to you.
Hmm.
Can you tell me network part and host part?
192.168.1.10 is the network part and host is 32 minus 24, which is equal to 2 raised to, which it will be 32 minus 24, जो भी नंबर होगा उसका 2 raised to that number.
वो तो आईपी कैलकुलेट करने के लिए है, बट मैं अगर होस्ट पार्ट और नेटवर्क पार्ट आपसे पूछ रहा हूँ, 24, हाउ मेनी ऑक्टेट यू हैव? ऑक्टेट 1 8 बिट, ऑक्टेट 2, ऑक्टेट 3, ऑक्टेट 4, 8
Hmm.
बिट 8 बिट 8 बिट, 192 168 1 0, right? Correct? Slash 24, slash 24 means first 24. This is 8 bit. This is 8 bit. This is 8 bit. 4 bit belongs to
Network.
network. This is gone, this is gone, this is gone. This portion. So here 192.168.1 would be
Network.
network. And
Yeah.
.10 would be host. Only this will move. Only this will move. So here 24 का जो है 32 minus 24 is equal to 2 power 8. That means 256. So 256 IP, but this will only move.
Hmm.
You're getting my point?
Yes.
Huh? Yeah. So let's look at this example. This will definitely give you some better idea. You are an AWS architect at a small company and you have been asked to set up a networking infrastructure on AWS. The company needs three separate departments, marketing, sales, finance, to have their own isolated network within a single virtual private cloud, that is VPC. Additionally, you want to allocate 5 more subnet for future use. So basically what happens here, a requirement comes to you, okay? And basically you want how many subnets? 8 subnets. Why 8 subnet? 3 subnet inside VPC, one for marketing, one for sales, and one for finance, and 5 more subnet for future use. So total 3 plus 5, 8 subnet. Clear? So basically, inside VPC, you need to have how many subnet? 8 subnet. Now to achieve that, let's say we have steps to address this requirement. Step 1, you decided to use this CIDR range 192.168.0.0. I'll tell you why did I choose 192. You can choose 10.0.0.0, but there are 3 types of IP address and we'll see later. But for now, you have chosen 192.168.0.0/16. This means VPC will have IP address range 192 to 255/16. What does it mean? You tell me. 16 network bit they are blocked,
Yes,
and 32 minus 16 is equal to 16. That means last 2 octet will change. So you can see last 2 octets are changing. You're getting my point? So your range would be between 192.168.0.0 to 192.168.255.255.
understood.
So now we need how many? So we have VPC CIDR. VPC CIDR is 192.168.0.0/16. This is what you have decided. But you have to define the range of subnet as well. How many subnet you need? Please
Eight
tell me. 8. 8 means bits required,
bits required. Eight.
3 bits. That means binary 2 power 3 is equal to 8. That means 3 bits. So new subnet mask would be new subnet mask would be this is your VPC subnet mask 16. 16 plus 3 is equal to 19. That's how you calculate. I'm showing you the formula. I'm showing you the way. You need 8 subnet. 3 is equal to 8. If you, for example, if requirement comes, you need 4 subnet. That means now you show me the maths. You tell me the maths.
Raised to 4. That-
No, 2 power 2 is equal to 4. That means 2 bit. So here 16 plus 2 is equal to 18. So slash 18 आएगा इधर पे. मैंने एक और एग्जांपल दिया. Let's further simplify it. So what did we see? हमारी range क्या है? Let me remove it. So we decided to use CIDR range 192.168.0.0/16 for your VPC. That means VPC will have IP address ranging from
92.1.
first 2 octet will not change, last 2 octet will change, each octet 8 bits. But let's not too much talk about octet, otherwise unnecessary. We'll make it complex. You know the concept. Let's move forward. Step 2, you need 3 subnet for the department and 5 subnet for future use, making it total 8 subnet. 8 subnet, how to get 8 in binary? 2 power 3 is equal to 8. That means 3 bit. You need 3 bit. Calculate the number of bits needed for subnet to create 8 bit. You need 8 subnet, you need 3 bits, right? Calculate the subnet mask. The subnet mask is calculated by adding the number of subnet bits to your VPC CIDR mask. What is VPC CIDR mask? Slash
16.
16 plus 3 is equal to 19. In this example, VPC CIDR mask is 16. So you are allocating 3 bits for subnet. So the subnet mask will be 19. So all the 8 subnet will have subnet mask as 19. Determine the subnet mask CIDR range. You can use the formula. Now, this particular URL you should definitely visit. When you go through the recording, you please type this URL, and this URL will help you to calculate the CIDR ranges. But before that, it is important for us to know the concept. Now, the question is, if we move to the next slide, these are the subnet masks. These are the subnets. You see, 8 subnets. 8 subnet. Can you see? I have also given the range. Every subnet is having subnet mask as 19. Now we know how did we calculate 19? You're getting my point,
Yes.
right? Now, each subnet, how many IPs you can have this question to me. We definitely need to know how many IPs in each of these subnet thing, right? How to calculate that? So this is slash 19, right? What you need to do, 32 minus 19 is equal to 13. That means 2 power 13. That means 8192 IP. 8192, 8192, 8192, 8192, 8192, 8192. Clear? Now, if you do the summation of 8192 8 times, it would be 65,536, which is the range of VPC 192.168.0.0. 2 power 32 minus 16 is equal to 2 power 16 is equal to this range. So in AWS, that's the biggest range your VPC can have. Keep this in mind.
65,536.
Yes. Can we move on to the next concept? It is clear, right?
Yes.
Now, this example I have given 8. Generally, we don't have 8,000 IP in each subnet. For simplicity, I gave this example. But I will not do like this in real world scenario, right? I will come up with a shorter range. I will assess the situation. But if I really need 8,000 IPs in one subnet, that case I will go with this. Okay. But blindly I will not. This is one example. Okay, to calculate it. Now, what we need to do? What is the next thing we need to do? What do we have? This we have already seen. We need to see how to calculate the CIDR range. For example, you have this example 192.160 slash and desired subnet 4. Now you tell me without looking at this slide, even if you look at that's okay. Another example, desired subnet 4. You need 4 subnet inside your VPC. That means
Additional bits required.
how many additional bits required? 2, because 2 power 2 is equal to 4.
Mm.
So 16 plus 2 bits is equal to 18.
Yeah.
Correct? So subnet range, subnet mask would be 18.
Yes.
Now, one more point I wanted to discuss with you. Let's look at some example before we start doing the hands-on, right? I think let's discuss few more examples that would be better for you to visualize. So let's discuss the first example. You have you have this range 10.0.0.0/16
Mm.
and you need 4 subnets. This is your VPC range. Now you tell me quickly, what would be the you know subnet masking for subnet? And what do you see here after forward slash? What
18,
would be the new mask?
18 would be the subnet mask.
Perfect. Slash 16 plus 2 because
4.
2 power 2 is equals to 4, right? Slash 18. So that's okay. Now you know it. Great. But what would be the range if I tell you this is VPC, right? And
Mm.
how many subnet you need?
4.
4. First subnet 10.0.0.0/18 and inside it you have IP range. Second subnet 10.0.0 10.0.64.0 18 10.0.128.0 18 and fourth one 10.0.192.018. Now, can you tell me how come this 64 comes, 128 come? Every time I'm adding 64.
4.
How did you get this? Inside it, you will have range, IP range, but this is the subnet, 4 subnet. So all the IP will come inside it, right?
Same.
Any idea?
This last two bits, I think.
I will tell you. I will give you more example and I will tell you. But what I'm telling you that this is going to be bit not complex but bit tricky. See here what you need to do. I'm just telling you the formula. 18. This is your subnet range, right? Now if you delete 32 minus 18 is equal to 14.
14 plus
Yeah. 2 power 14. How much would it be? Let's calculate that. Five, eight, 16,384. 16,384. These are the IP. 16,000. 16,384. It's not working.
against Steve Chigates.
16,384. You divide by 256.
Divide this number by 256.
Yes.
Take what it is.
How much you will get?
64.
And I just showed you the number was moving from 64. So every time you need to add 64, correct?
Hmm.
I'm not sure why it is not working. I hope you got some idea. I could have explained it better. This pen is not working, but we'll do it here
Hmm.
in the slide because in Zoom link it's not working. So you got it right. We'll see some more example. So what you need to keep in mind, I'm going to, so basically you just calculate the block size. We call it block size. For example, 2 power 13, that means whatever number comes, it is nothing but your block size, right? So I will share one formula with you so that it would be easier for you to remember. Even if you don't remember, that's perfectly all right because there are various ways to find out. It got stuck. Anyway, let's move on to the next slide. We'll discuss. This pen is not working. Calculate the subnet CIDR range using new subnet mask. We have already seen this. We have seen this, yes. So now this slide is important. Slash 24 network bits is 8 plus 8 plus 8, 24, right? If you see slash 24, that means host IP bits start from fourth octet. That means only fourth octet will move. Will move means IP range will move in fourth octet. You are getting my point? Yeah. 25 means again fourth octet. How?
20.
No, no, no. 1, 2, 3, 4, 5, 6, 7, 8. One octet.
Yeah.
1, 2, 3, 4, 5, 6, 7, 8. 16. 8 plus is 16. 17, 18, 19, 20, 21, 22, 23, 24. Third octet. 25, 26, 27, 28, 29, 30, 31, 32. So these are 4 octet, 1, 2, 3, 4, 8 bits. This is 25. This is 8 plus 8, 16 plus 8, 24. 25, this is 25. That means 4th octet will move. This is 4th octet, right? This is third. This is second. This is first octet. You are getting my point or not? 26, again, 8 plus 8 plus 8, 24 plus 2. That means 4th octet. 20, 8 plus 8 plus 8, 16 plus, no, sorry, third octet. 8 plus 8, 16, 17, 18, 19, 20. So you can see third octet here. Can you see this? 19 again, third octet. 18 again, third octet. You're getting my point? I'm making sense to you, right? It is not so overwhelming. थोड़ा समझ में. Now we have seen subnet range, each subnet associated with IP range. Address represents CIDR block, right? We have already seen availability. Those subnets are tied to specific AZ within a region. Keep this point in mind. Subnet spans, to availability zone, not beyond it. Public subnet versus private subnet, very important. You will play around with all these things, right? So you have VPC, you will define the public and private subnet, right? Public subnet have a route to the internet gateway. What is internet gateway? We will see. allowing the resource to have public IP address and communicate directly with the internet. So all the resource in public subnet, why would you place those resources? You will place the web servers in the public subnet so that your website can reach out to the internet. Correct? Private subnet do not have a route to the internet. But you have to provision the resource, you have to have the net gateway or different ways to have the communication but to internet, but direct internet connection for the resource which live in private subnet. Unka use case web server. Public subnets are typically used for web server that need to be accessible from internet. Database, always you will keep database. Where would you keep the database? Please tell me. In private subnet, right? Correct? Because database is the most important thing of your application. Database where your data reside. So you will always want to keep the database in private subnet. Best practice, separate subnet for different tiers. So that's best. What does best practice is someone asks? You can keep web server, you can keep web server in public, but you will always keep database in different subnet, right? Properly sized CIDR block to accommodate future growth. This is this point. Properly sized CIDR block to accommodate future growth. I just told you, right? Some time back that you have to design you have to come up with the CIDR range, classless interdomain routing for the VPC, and you have to come up with the subnet with the range. You have to discuss with application owner that you need to give me the idea of growth of this application. Okay, so that I can design the application, I can come up with the IPs accordingly. So it would not be like you have met the requirement for now. Key points to remember for subnet. AWS, हाँ ये AWS specific है. AWS reserves 5 IP. तो for जितनी भी आपने IP calculate की, for example, if you calculate 256 IP, if calculations say you have how many IPs? 256. You will end up using 256 minus 5. That means you can use only 251 IP. 251 IPs will be available for you to use because AWS always reserves 5 IP from your VPC range. मैं उस पे आ रहा हूँ. First 4 IP address and last IP address is reserved and you can't allocate them. First 4 and last IP. Let's use one example 10.0.0/24. This is your, let's say, VPC range. So following IP address will be reserved. First IP network address के लिए AWS reserve करता है. This happens behind the scene. You probably never get to know it. But ये at least solution architect associate level में एक question आता है. So फर्स्ट आईपी इसको यूज नहीं कर पाओगे आप. नेटवर्क आईपी, द नेटवर्क आईपी इज द फर्स्ट आईपी एड्रेस इन द सबनेट आईपी रेंज एंड इट इज यूज्ड टू आइडेंटिफाई सबनेट itself. This IP address cannot be assigned to any individual resources or device within the subnet. It's as a reference point for the subnet and use network device and routing protocol. See, in practical usage, you don't even need to care about it. What you need to care about the number of available IP for you. -5 would be the available IP for you, whatever range you come up with. You're getting my point? Second, one reserved for VPC router, reserved for AWS mapping Amazon provided DNS, reserved for AWS for mapping to Amazon provider DNS. This is third. Fourth, reserved for future use. Fifth, network broadcast IP. Broadcast IP is the last IP address in the subnet range and it is used for broadcasting message to all the device within the subnet. So if you need 30 usable IP in the subnet, you can say I will use 27. That means, okay, if question comes, you need 30 usable IPs, AWS specific questions, 30 usable IP you need. What would be the range you will choose? 27 means 32 minus 27, 5 means 2 power 5 means, but this, that means 32. 32 minus 5. I think there is something wrong. If you need 30 usable IP, but it is not. Acha, it was bit tricky. But this is not right answer. I forgot that it was a tricky question. So will you come up with 27? Answer is no. Because if you need 30 usable IP and your output get 2 power 5 is equal to 32, how to get 2 power 5? That means 27. 32 minus 27, 5, 2 power 5, 32. 5 IP will be used by AWS, will be kept by AWS. So you will end up having 27 IP, but requirement is for 30 IP. So you will use slash 26. That means 32 minus 26. That means 2 power 6, 64 IPs. Clear? Now, we are going to do so many hands-on, you see. It's a very nice hands-on I designed. Let's run our first hands-on and then we'll close today's lecture.
Hey everyone, we are going to start our first hands-on on AWS networking. When I say AWS networking, that means VPC, Subnet, and all other network component. So as you can see, I am in AWS Management Console. I have created a diagram, right? And using this diagram, we will visualize our hands-on. So what is the first step we are going to do? We need to be in US East 1 region. You can be in any other region. And if you want to do the hands-on in UST one region, you are free to do it, right? So as you can see, we are in AWS Management Console and we are in US East 1 region. It is also called North Virginia region. What is the next step we need to perform? We need to create the VPC. Can you see it here? With the CIDR range 10.0.0.0/16. So we will get 65,536 if I'm not wrong. And you guys are the expert now. You should know by this time because we have gone through in theory lecture how to calculate the CIDR range. /16 means 32 minus 16 is equal to 16. 2 power 16 is equal to, it should be 65,536 if I'm not wrong. You can do the calculation. So let's create the VPC. As you can see, VPC is spread across region. So let me quickly type VPC here and let me create VPC. Let's click on create VPC. Now here you need to select VPC only because we want to create all the components to learn the basics. Intention here to learn the basic, then only we would be, do the complex solutioning. Now name, let me type name demo VPC and then CIDR range we are going to put 10.0.0.0/16. Now tenancy wise we are going to select default. In most of the use cases still now in my experience I have never used dedicated tenancy. I have been using default tenancy, but let me very quickly give you the difference between default and dedicated tenancy. What happens with default tenancy? When you create the VPC, right, with default tenancy, it means that the instance launched within that VPC will run on shared hardware. And what about dedicated tenancy? Dedicated tenancy means when you create a VPC, as we are creating, with dedicated tenancy, it means that the instance launched within that VPC will run on dedicated hardware, not the shared hardware. That is the difference. All right. But I would say from 99% use cases, you will use default tenancy because this will solve your purpose. It is cost optimized. It will do the cost saving. Dedicated is expensive. When you use dedicated tenancy, you will use dedicated tenancy when you want to provide additional layer of isolation, and it is suitable for scenarios where you have strict compliance and regulatory or security requirement. So let's select the default tenancy and let me click. I'm not creating any tag. I'm not giving any tag. Let me click on create VPC. So our VPC create. As soon as you create the VPC, guys, you can see a default main root table. It gets created when you create the VPC. You have the main network ACL and we will do a hands-on on ACL network access controllers. So these are the details of VPC. Let's get back to our diagram. What is the next step, guys? you can see two availability zone, but you guys are aware because I have already shared the basics of availability zone and relation between region availability zone. In one region, we can have more than 3 availability zone as well. But here I have depicted 2 availability zone because we are going to create serve subnets in 2 separate availability zone. One thing you need to know, and probably I have already shared this information with you, that one subnet cannot go beyond availability zone. There can be multiple subnet in one availability zone, as you can see in this diagram. But public subnet cannot, if it is in US East 1A, can you see my cursor? Right? It cannot go to availability zone US East 1B. Let's create first subnet. I have also depicted the CIDR range. It will start from 10.0.0/18. I am not going to discuss how did I come up with 10.0.0/18 because you guys should be able to calculate, but just let me give you an idea. We had to create, the requirement is to create the first subnet. That means we need 2 bits, right? Correct? Then 16 plus 2 is equal to 18, and that is why /18. So let's click on, in left navigation, click on subnet and click on create subnet. VPC we need to select the same VPC which we have created, right? All the subnet will be beneath this VPC. Let me give a name to first subnet, public subnet A. Availability zone, when and we need to place it as per diagram UST1. Can you see UST1? Let's go ahead. CIDR range of VPC 10.0.0/16. Now the subnet range would be first subnet 10.0.0.0/18. That is the range you need to decide, and right after that you can utilize this website. I talked about this website in the theory lecture, right? IPaddressguide.com will help you to find the first and last IP of your subnet. So first subnet range, first CIDR range of my first subnet is 10.0.0/18. Let me place it CIDR range here. Let me click on calculate, and that is how you will get the first IP of public subnet A, 10.0.0/0, and last would be 10.0.63.255. You guys must be aware that IP address in the last octave cannot go beyond 255, as you can see. So what would be the next IP for the subnet, public subnet B? It would be 10.0.64.0. Let me click on add new subnet and public subnet B, availability zone UST1A. You can see in the diagram, this is the second public subnet 10.0.64.0/16, and CIDR range would be 10.0.64.0/18. Now you copy this and let's find out the subnet range for the third CIDR range for the third subnet. You can see first IP 10.0.64.0 and last would be, you need to add 64. If you have closely observed it, first IP and the next name by adding 64, 64 plus 64, 128, 128 plus 64, 192. So next IP, what should be the next IP, guys? 10.0.128.0. So here, let me create a new subnet and private subnet B represents US1B. You can see in the diagram US1B. You need to send my cursor, and here 10.0.128.0/18. Let's quickly copy it and let me paste it here. First IP 10.0.128.0. Last is third octet says 191. So next IP would be tiny, guys. What would be the next IP? It would be private subnet B. IP would be 10.0.192 because here 191. So next IP would be 192.168. 0/80 and we are good. Let me click on create subnet and all the subnets are created. Okay. So we are done till here. You have done the VPC and subnet. Now you are good to deploy your resources. When I say resources, that means let's take an example of EC2 instead. What are we going to do in next lecture? I will show you right after this lecture. I do not want to make this lecture lengthy, so I'm closing it now and I will see you guys in the next lecture. Thank you guys.
You got it right? It was clear?
Yes.
Since you have some idea about it, I want to share one nice formula because you could have a question that ये आईपी जो सबनेट फॉर एग्जांपल 4 सबनेट हैं या 5 सबनेट हैं या 3 सबनेट या 2 सबनेट करते हैं आई एम श्योर यू हैव सम आइडिया फॉर एग्जांपल how to play around with security group, what is route table, what is bastion host, what is net gateway, what is internet gateway, what is NACL, what are VPC pairing, what are endpoint. I will try to do the demo of how to make connectivity between on-prem. We'll do the simulation. We don't have on-prem, right? How to do the simulation from IPsec using IPsec tunnel using on-prem and AWS. So all these things we'll go through, and by end of networking, you'll have a very nice idea about AWS network. All right.